Hello, my name is Boriss Mejias, Solutions Architect from EDB. And in this presentation, I'm going to try to show you how to use the JSON data type in Postgres for the best. Because some people have trouble with this data type, they even consider it evil, and they think that the B in JSONB is for beast. But we can tame this data type so that it provides you the best for your database schema, and that you're actually going to enjoy this data type and love it as much as I do. So, JSON in PostgreSQL. This is, as I said, there is two data types: JSON, which is the most basic one that just supports the basic stuff, and the JSONB. And this is where people start thinking, like, is this for beast or not? Because I'm seeing some evil behavior. And actually, it is not like that when you learn how to work with it. It's like kind of, it needs some comprehension, it needs some care. And we're going to show you not syntax specific stuff, not super complex queries on JSON. It's more about designing your data schema so that it matches what you need JSON for. And why do you need JSON for? I mean, why does people want to use JSON anyway? Well, the major reason that I think that people want to use JSON is not just because the objects run on the application with JSON objects, but it's because of schema freedom. Usually freedom is actually associated with evil stuff. That's why heavy metal music always talks about freedom and these kind of topics. And they say, like, oh, this is evil music. But no, it's just freedom what we are searching. So let me explain you a little bit what I mean by freedom in terms of data. Imagine that you have a collection of images, documents, videos, and all of them have a name, some attributes like when it was created, but they also have different type of data, metadata, based on the type of object that you're using. For instance, an image, we have its height and width, which is specific to a picture, not to a PDF, for instance. But then some pictures, they will have also, if you took it with your phone, or you add it then afterwards, a latitude and a longitude to specify where this picture was taken. For instance, in this case, coincidence, it is in the place, the first venue that I saw a metal band playing in Chile. Now, in the other one example, for instance, you can have also the container of the video, which is OGG, for an interview of a Slonic talking about Postgres, which is exactly the same time of one of my favorite metal songs. Now, if you want to have a use case to understand better what we are going to be talking about, it's always nice to have something that you understand. And I understand metal music, and that's why we're going to be using it again. Now, let's look at JSON object describing a metal band. The metal band, if you want to put it into your database so that you can find it and then associate all the data with this metal band, it will need to have an identifier, and then it's going to have a name. In this case, we're going to use the Swedish metal band Ambush, which has some different genre of music. This is from the new wave of traditional heavy metal. They started in 2013, and they are still playing until today. And the songs are about evil stuff, occult stuff, but also a lot of stuff anti-totalitarianism. Very long word, but it's a type of music that they use. Now, all this type of information that I gave you about the band Ambush could be completely differently structured for a different band, and that's why we have this freedom with JSON objects. Now, the JSON objects, we are going to have to put them now in a database to find information. So this is where we are going to see whether it's going to fit or not into our structure. So we are going to create a table, and I was discussing with a good friend about the usefulness about pen and paper. So I do my drawings about data schemas with pen and paper first, and then I try to match it into code. So in this case, I have a table, an entity, which is bands, and it's going to have just one single JSON object. Now, what is going to happen is that this metal band is going to just have the band, JSONB object, and that's it. Another recommendation here, usually we don't use the public schema because it's too mainstream. But we created here the schema metal, and it actually, the table itself reads much better. This is metal bands. Yeah. Okay, so we have our object there, and we say that we want to identify them uniquely. By name, it might be a little bit difficult because if you search for bands named Ambush, there are many of them. Actually, the one that I like is called Ambush Sweden or something like that. So what we want to have is an identifier, a number that is going to be unique. And see people say like, this data type doesn't give you this uniqueness of key. Well, you can do it in Postgres. And if in Postgres you say, I want to create a unique index on the metal bands table, using, and here you're going to see that in parentheses, double parentheses, I have the attribute band with an arrow, with a double arrow. That means I'm going to go inside that field and inside a little bit more to extract the text from it. That text, which is on the field ID, it have to be unique. So we'll never have duplicates on this JSON collection, which is very good. So it removes a little bit that this kind of lack of relational properties. We are going to see that it's not enough, but at least you can do it, which is good. So let's look at albums, because metal bands, they play live concerts, which is the best thing to have, but also they record music in albums. In this case, we have 3 albums, the last albums from the band Ambush, and they have different years, and they have an ID also as a band, as an album, and they refer to the ID of the band as well, which is a typical design that one band has many albums, right? So we draw it on paper, and we have this. Now, the thing here is that you get a little bit complicated, and here's where we see the limitations, because how do I refer from the album to the band if I have JSON objects? I can have uniqueness of IDs, but I cannot have foreign keys, and we want to have foreign keys. So what we are going to do now, it is in our design to extract this bad behavior, is that this unique ID, actually, we're going to turn it into a primary key. So instead of creating the table like that, I'm going to create it actually with one attribute, which is a big integer, and it's my primary key, and I'm going to move it out of the JSON object. So this is the first principle. When you see that there are some things that are more useful outside of the JSON object, you can do that, no problem. And then what I'm going to do now is I'm going to create the metal album, not even as a JSON object, because they all have an ID, a band ID, which is a foreign key, as you can see here, references metal band ID, and a title, which is the name title of the album, and then the year that the album was published. Then you're going to have songs that refer to the album, or you have an JSON object with all the songs there. Yeah, it depends on how you want to shape your objects. Okay, so now I have this diagram where I can clearly see where is the reference from the band to the from the album to the band that record this album. All right, now obviously there is a lot of opinionated people in the world, and they make reviews of albums. Some of them are very useful, and so we're going to talk about those people who really want to talk about the music in a very objective way, and not just being like, oh, this band that sucks. But anyway, so let's look at this one. It's an example about one of the bands, one of the albums, sorry, and it talks about how this Swedish racing force is more evil than ever in this last album, the evil in all dimensions, of course. Interesting here is that it has its own ID, the review, but it refers to the ID of the album. This is going to be useful that we have this as a primary key, so we can refer to it as a foreign key. But look at it, the two fields, score is a float number or a double number, a real number, and then from 0 to 1, and then you have the content of the review, which can be a very, very long extended text. We are going to get back to that. So the two first one, we are going to take them out of the JSON object, and we are going to use them as primary key and foreign key. So here we have it. ID, album, primary references the other one, and then you have the object with the entire review. Now we complete our design, and we have a very beautiful relational entity relation diagram, which I think it's very useful to establish some properties of uniqueness and integrity of your data. So let's look at how we use the JSON object now inside each of these tables. Let's index stuff, because if you just do full scans, it's going to be too slow. We know that. It's going to load too much data on the RAM. So we just want to create some indexes, and sometimes we're going to resolve some of the queries just by using the indexes. So let's see some of the possible indexes that we can use. It is said in the documentation that if you have a composite value, for instance, like a JSON or an array, use gin. Yeah, it's like in some bars they say, like, if you want to drink tonic, put gin. In the same case here, composite gin. That's it. Gin is for inverted index. That's the I and the N, and it means that it's going to take the elements that are inside your composite, and it's going to create an inverted index going from those to the places that it have to find the information. Right, I'm not going to go into too much details of that, because that would be a completely different presentation. But let's look at the album here, sorry, the metal band ambush. Yeah. We are going to take this object into a table that we set. We have the ID as one particular column, and then we have the band, which is the entire object. That object actually is what we are going to index as a gene stuff. Yeah. So you create your index on the metal bands table using gene, and then you put into double parentheses the band itself. So you take the object that is inside the band and you can index that. Now that might not be as useful, I think, but it's possible. So you can start with that and see where it goes. The problem is that people say, "Oh, but this stuff is evil. Look at the size of my index," because the size is almost the same size of the table. Yeah, that's true. So let's go a little bit deeper and see where do we really need indexes, because indexes are useful based on the queries that you run on it. For instance, I would like to search for names of bands or the style of music that they play, the genre. Okay, so let's look at this. Here's our table. We have here that the genre is not only one type of, well, some of the bands, they have one, they just play thrash metal. That's it. Or some of them just play like black metal and they stick to black metal until they die. But this one plays either heavy metal, speed metal, or now it's called new wave of traditional heavy metal. So you have multiple ones. That's why they are inside an array. And that's beautiful in a JSON object. So that's a composite inside a composite. So we can actually index that particular one. So let's do it. So we create an index for the genres of a band using gene indexes. And we, in this case, look at the arrow. It's a single arrow. If I would have put a double arrow there, I would go inside the field and I would extract the text. And that wouldn't be so good for a gene index. A text is not good for a gene. Well, in some cases, yes. But I want to have the elements of the array. So I want to have the object. That's why I use a single arrow there. Band, single arrow, genre. Okay, but I can create other stuff. What about B-tree indexes? Well, if the value is a scalar value, just text, for instance, then I can use a B-tree. So for the name of the band, this one, look, I'm using the double arrow because I want to extract the text of the field, which is the name, and then I can index that with a regular B-tree index. Yep, this is what we usually have for every column in Postgres. So as you can see here, now we have the object and we have two types of data inside the composite. One is text, one is array, and we use two different type of indexes depending on what we are using. And that's how we start taming this beast. We start understanding how it behaves. We understand how the data inside is being stored. And this is what is going to make us work more with the developers of the application because they know more about the data, and the DBAs are going to also be helping you to create the indexes. So this is about collaboration between human beings as well. All right. So there is another directive, as I said, composite use gene, that says that for text use trigrams. Trigrams is a super underrated type of index that I love it. It takes the distance between three characters and like that is going to find similarities and it's going to be super fast. The size of the index is also quite small compared to other type of text search stuff. I also have some pictorial things and it's very, very powerful. And we can use it here with gene. And this is a way of using gene with text for one particular one that I think is interesting. We are going to look at again at the metal album reviews. And in the reviews, we find that the content, it can be very, very large because here's where the journalist or the metal fan is going to start writing and writing and writing about the album, all the passion, all the emotions, everything that comes by listening to this album. All right. So that particular one, so you see we have a table with three fields. The third one is the object, and then you have inside that object the content. That's the one that we are going to index with trigrams. So we do it like this. Before we create the index, we need to create the extension. Create extension. This is just in Postgres contrib. You don't need to install untrusted code that you don't know who is maintaining. This is from the Postgres contrib. And then you put it in the schema metal, the one that we are using, and then the index is going to be created as follows. We say the name of the index on the metal reviews, and then using gene, but with the operation of the gene trigrams operations. And again, I'm not going to get the object that is inside the field, but I'm going to get the text that is inside the field. That's why I'm using the double arrow. Okay. All right. So now we know how to use the correct type depending on what structure of our JSON object is giving us. Let's continue now for some other stuff. They say like, okay, but I still don't like it. People say all this dynamic data typing. I want strong typing, especially if you like metal, something like strong stuff. There are some very soft sounds as well, especially I would say the emotions are strong, but talking about soft feelings as well sometimes. Heavy metal goes much more beyond the mainstream comprehension that we observe from the outside. So we want strong typing. How do we do that? Let's say that we were talking about the score of the review that goes from 0 to 1. That means that I want to have there a double precision type of value if you're talking Postgres term, a real number if you're talking in mathematical terms. So that particular one, what we are going to do is we're going to create an index which is going to cast the text that comes from that field. That's why I use a double arrow. I'm going to say, cast this into a double precision. If somebody tries to insert a JSON object where the field score is not a double precision, this is going to fail. So it's going to guarantee you that every time that somebody puts a score there, it has to be matching double precision. And this gives you a strong typing for fields inside a JSON object. Some people praise the fact that said, then we should have schema definitions for all the fields in the JSON object and be explicit about all the specific data types. Well, but in that case, why don't you just use columns? I mean, I like JSON objects because they are dynamic when you need them, and they can be with some guarantees when you want them to be like that. Like I want to have a unique value for this field, or I want to have all these values being double precision, which is with this index. And so like, isn't it weird to use an index for a constraint? Well, yeah, an index is kind of a unique index, for instance, is a constraint, basically. But you can also just add a constraint. So let's do it like this. We alter the table metal reviews, we add a constraint, numeric score, and we are going to say, check this constraint, which is the function pg input is valid. So we're going to validate this input, which receives two arguments. One is the score, and the other one is the type that we want to get, double precision. If it fails, it's not going to accept this value. Now, the index, of course, is going to help us also to search for, give me the reviews that are in value higher than 0.666, just to give you a number randomly, All right, good. So there are some type of JSON things that you could use, like JSON and SQL, like this one, for instance. I'm going to add a constraint, which is called scalar score, which says that the objects that are used in our single arrow is a JSON scalar. But be careful, this one is not going to be guaranteeing a number. It can be also Boolean or a text. It just guarantees that it's not an array or another JSON or something else. Well, look at the documentation of scalar. I might be wrong about all the possibilities there, but it's not just numbers. But this gives us an opportunity to like, if I can say like, if this is something JSON, I could use it for something else. And remember that we were doing an index, which is a gene index for arrays, which means that for the genre, so I want to have the genre always as an array. If somebody by accident put just black metal, because it's the only style that they play, it should be an array with one single value, which is black metal. So we can add then a constraint saying that the genre have to be always an array. And like we do like that. The object that comes in the field, that's why I use only one single arrow, is a JSON array. And like that, we guarantee that. And our index is going to give us good results. Gene is also going to be able to index all the stuff, but I mean, we want to have arrays, otherwise the index is not going to be helpful. All right, so let's get back to the concept of schema freedom. What do we mean by schema freedom? I mean, if I define it and I know what it is, I could just turn it into columns. But what if it changes later? Well, let's see some example. I want to have reviews that not only have these fields that I have, but I also want to add how many people like this review. So say, well, this one has 234 likes in this ID. So I can actually, like that, update the object by adding a new field. I don't have to do alter table and add a column, which is going to rewrite the whole thing. I can just add the field that I want in the object that I need. I can also say, okay, how many people reposted this? 134, fine. Or I can also say how many people share this without reposting it, so send it to somebody else, which is 1717, which 1717, is by coincidence the amount of people that fits into one of the rooms in Tivoli Vredenburg, which is the venue for PG Day Lowlands this year in September 10 in Utrecht. Okay. But I can have this dynamicity for free? No, there is a price to pay. And let's look at this. A tuple, let's say that I have a review that is 1 megabyte. If I look at multi-version concurrency control, at the moment it's just using 1 megabyte. But if I update it, I'm going to create a dead row, and that is going to cost me 2 megabytes. If I update it again, 3 megabytes. If I update it again, it's going to use 4 megabytes. The tuple is still 1 megabyte, but it's using 4 megabytes. So when you are accepting clicks of somebody in an application, instead of adding them to the database immediately, what you could do is to wait for all the changes in that article and put them all at once. So this is how you tame your JSON beast. One object that contains 3 new fields, you add them there, and the tuple is still going to be 1 megabyte, but it's only going to be using 2 megabytes as your multi-version concurrency control system. Much more efficient. Now, there is one concept that I'm going to introduce here that I haven't seen it before. It's called FOF, is candidate for columns. What a FOF means, it means frequently updated fields. Likes, posts, and shares are going to be updated frequently, so we are going to put them as columns. You see? The advantage here is that now I can update those without touching the JSON object, because these are frequently updated fields. So I take them out of the object. And I can do things like this. In this case, the tuple is still 1 megabyte, it's not smaller, but I can just change those columns. And then the multi-version concurrency control is only going to add the row that is fixed size, and it's going to point to the JSON object. So in general, I mean, unless the JSON object fits into the block, and that means that the JSON object is such a small thing that you don't care. But if this JSON object is large enough, it's going to go into what is called a toast table. And the toast table is just a reference. So you just update the things that is fixed, and then you just say, okay, and my object, JSON object, stays the same, so it doesn't going to increase my usage into the table. I think that's a nice way of naming the beast. All right, this thing I'm going to just mention it briefly. I don't believe too much into the usefulness of this, but since this was a question from one of the people who asked me, okay, what about partition table with JSON data? Is it possible? Yeah, you can do this. So for instance, you can have a new table called venues. You see, it only have one, we don't, because we don't know yet what type of information we are going to put up for the venues. So we're just going to have a JSON object. It gives us the freedom. But what we know is that we are going to sort them by country. We're going to partition them by country. So this is a table partitioned by a list and is depending on the text value of the country. And I'm going to just create 2 partitions, one for the metal venues in Chile, there are many, and the ones that are in Belgium. And as you can see in Belgium, we don't know whether we write them as Belgium, Belgia, or Belgique, because depending on the language that you're speaking here in this country. So there you go. You can do partition tables also with JSON objects. I don't know if that is useful, but it's possible. Okay. So some closing words. So let's wrap up all the things that we were discussing here. The reason that I love JSON is because it gives you this freedom. I like freedom in general, in combination with some agreements that you need to have so that everything flows in a relaxed and natural way. Okay, so you mix this freedom with some relational best practices in the way that we took some volumes out of the JSON, convert them to primary keys, and then we were able to do foreign keys. So it gives us the guarantees and the integrity of your data. So extract every useful field out of the JSON object and put it as columns. We saw it in a few examples. Then when you want to index inside the JSON object, make sure that you understand your JSON object and you use either gin or trigrams or b-trees or whatever fits better for your use case. And you can also add constraints on your type. So you can say, in this particular field, I only want to have double precision values. I only want to have arrays. And with that, I would like to close this, but as an invitation to continue this discussion, you can do that in the Discord channel, because this is a recording. And if you are watching this live, I'm going to be trying to answer questions there. But also afterwards, we can discuss about new opportunities of using JSON. Some of the stuff that I presented here today are actually questions that I got in previous presentations or in just discussions with people. And also, if you don't care about JSON, but you care about music, not even metal music, but music in general, or connection between people, you can also contact me, and we can always have a chat about how music connect people, how designing databases connect DBAs with developers, and how we can make a happier world if we all collaborate a little bit more. So thank you very much, and please feel free to reach out.